Thank you very much. It's good to be with you today, and I'm going to defend what I believe to be the straightforward reading of Scripture, that God created the earth in 6 days. What is at stake in this debate? And if you could go ahead and just leave the PowerPoint up, I'd appreciate that. They don't want to see me. They want to see the pretty pictures anyway. What's at stake in this debate? Well, biblical authority, I think, is at stake. Do we allow the Bible to determine its own meaning, or do we allow the outside influence of secular scientists to tell us how we ought to read the Bible? That is a big issue, and that is at the heart of this debate. Biblical inerrancy. Is the Bible accurate when it speaks on matters of science and history? My colleague professes to believe in biblical inerrancy, but then the issue becomes biblical perspicuity. Is the Bible clear? Does it really mean what it says? Can the average person read the Bible and come away understanding what it means? And I believe that you can, and I believe that 6 days means 6 days. The gospel message actually ties into this debate very strongly, because the gospel message is predicated on the fact that Adam's sin is what ruined the world. Adam's sin brought death into the world, according to Scripture, right? But if fossils are hundreds of millions of years old, you got death before Adam sinned. And that is theologically significant, because if death is not the penalty for sin, then why did Jesus have to die on the cross? So you see, the gospel is connected to this. It is important. We're here to talk about the science this morning, though, and I want to delve right into that. Astronomy is the branch of science dealing with objects and matter beyond Earth's atmosphere. It's always important to cover definitions when we do debates like this. The key word here being science. Astronomy is a branch of science. It's very important, because science is knowledge about or study of the natural world based on facts learned through experiments and observation. And those are the key words there, experiments and observation. Science is not the only way we acquire knowledge. There are other ways. You can read a history book and you can learn things, but that's not science, because science involves experiments and observation. If you're not doing experiments and observation, you're not doing science, and therefore you're not really doing astronomy. So, operational science, which is the kind of science that puts men on the moon, makes your computer work, makes PowerPoint presentations possible, that's the study of the way the universe functions today. That's real science. Observations and experiments are always conducted in the present. And that should be pretty obvious, right? We can't go back in time and do an experiment, and that's going to come to bear in this debate today. Age. What is age? Age is the amount of time during which a thing has existed. That's just the dictionary definition of age. Age is a concept of history. It is a concept of history. It is not a substance that can be measured in the present by scientific means. And I hope that's clear, but people have misconceptions about it. They think, you got this rock and it's got a certain amount of age in it. And you measure the age, you point your tricorder at it, and it scans it, and it tells you the amount of agicles in there. No, age is not a substance that can be measured scientifically. It is a concept of history, and therefore, it's not something that can be measured directly by science. The tools of science do allow us to measure in the present things like length, volume, mass, force, density, barometric pressure, velocity, acceleration, energy, but not age, because we cannot observe or experiment on the past. We can't. It's gone. And so we can't touch it scientifically. Let's do a little experiment, okay? I want you to get out a laser, and I want you to point it at the moon last Tuesday. You can't do it, right? Because we can only experiment in the present. And so you see my point. Science can't really measure or prove age. It's very important to understand. To know the age of something, we must have information about 2 points in time. We need the information about when the object first came into existence, and then we need to know the current time. And so you need to know T1, when the rock first came into existence, and then T2, the current time, and you subtract T2 minus T1, that gives you the age. Now, of these 2 points, which one can be measured scientifically? Only T2, because I can look at my watch. I can observe that in the present, and so that qualifies as science. Now, I'm not saying you can't know T1, I'm just saying you can't measure it scientifically. What about the age of other things? What about the age of people? You can't measure the age of a person scientifically, right? Because you can know T2, we can look at our watch and find the current date. That's pretty easy. But you can't scientifically tell when the person came into existence. And I'm not saying you can't know a person's age, you just can't know it scientifically. You could find T1 by other methods. You could look at a birth certificate. That's a historical document that records when the person came into existence. That would give you T1, and you could look at your watch and get T2. In some cases, we don't know either T1 or T2. We can't tell when a dinosaur was born or when it died, and so we can't tell age there either scientifically. What about the universe? Are stars different? Are we looking back in time when we're looking out into space? Some people say that. That actually depends on the synchrony convention. We might get into that a little bit later today. But even if that were the case, even if you're looking back at time and you're saying, well, see, I'm looking at the star back then, millions of years ago. Well, then you're not looking at it today, are you? And so you don't know T2 in that case. You still have only one data point, only one point in time, and you can't determine age using one point in time. And by the way, when we do observations in astronomy, we're doing them in the present. And so I think it makes sense to talk about the universe in the present, really. We can discuss that a little bit more later on, perhaps. So it's impossible to prove the age of something scientifically. Now, we can have historical data and prove it other ways, but we can't scientifically prove the age of something because we can only experiment on the present. And to know the age of something, you must have information about 2 points in time, but scientifically, you can only know one at most. Since astronomy is a branch of science, and since the tools of science cannot prove a past event such as age, it follows logically that astronomy cannot prove the universe is old or young. You can't prove it either way. But that doesn't mean we can't make an estimate of age, right? We can use the tools of science to estimate but not measure or prove the age of something if we make certain assumptions about the past. What's an estimate? It's a guess. It's an educated one. It's a reasonable guess, as reasonable as we can make it. And it's sometimes called historical or forensic science. There's a couple of things you need to remember about historical science, though. First of all, any estimates about the past that we make cannot be scientifically tested or proved. You come up with a great guess about the age of a rock. Good for you. You might be right, but there's no way to scientifically prove it because we can only experiment on the present. Second, our age estimate will only be as reliable as the assumptions that have gone into it. And that is key because you, Ross, and myself, we make different assumptions about the past, basically, and that will affect our age estimate. So let's consider some of these assumptions that have gone into making an age estimate. I'll use a candle because a candle, we know it changes with time, and you can use that to make an age estimate, can't you? And let's suppose that you're watching that candle burn. You want to know how long it's been burning. You can measure the age of the flame, right? Can we measure that? Well, we can measure the rate at which it burns today. And so we'll find, for example, that maybe the candle loses 1 inch per hour. That's kind of fast, but it makes the math easy. Okay, so the candle's burning pretty quickly. And then what you can do is, now that's science right there, because we can do that repeatedly in the present. We can measure it in the present. And then we extrapolate into the past, and we say, well, assuming that it has always burned at 1 inch per hour, you go back until the candle reaches its initial height, whatever that is, and that'll give you T1. And then we know T2 by looking at our watch, and you subtract, and that gives you the age. But of course, that assumes that you know the initial height of the candle, doesn't it? And maybe you say, well, there's a factory that makes them, and it makes 1 foot candles, and today it's 6 inches, it burns 1 inch per hour. So 6 hours it's been burning. But maybe the company also makes candles that are 1.5 feet. You didn't know that. And maybe that's the one that it was. And if that's the case, then your age estimate will be wrong. Okay, because you incorrectly assumed the initial conditions. Alternatively, perhaps that somebody cut off the bottom portion of the candle and it's only been burning for a few minutes, but you assumed that it started at at 1 foot. You would incorrectly conclude the age to be much older than the true age of that flame. Now, we cannot scientifically know the initial conditions, right? Because you can't go back in time and see what they were. You can't observe the past or experiment on the past. But in some cases, they can't go beyond a particular value. And so that allows us to estimate an upper limit on the age, but not the true age. And as an example of this, salt in the ocean. Fresh water carries a little bit of salt into the ocean, because even fresh water has some salt in it, and accumulates at 450 million tons per year. You can get rid of a little bit with salt sprays, but the rest of it just accumulates. You run the equation backwards, and you find that the oceans, even being generous to the critics, the oceans can't be more than 62 million years old, because at that point they would be fresh water, and you can't have less salt than no salt. And so you see that's an upper limit. It's not the true age, it's an upper limit. The true age would be a few thousand years, 6,000 years, because the ocean started with a lot of salt already in it. So you see my point, hopefully. The point is that the biblical age of the ocean is 6,000 years, very different than the secular age, and yet the salt content is consistent with the biblical age because it puts an upper limit. A lot of the age estimates I'm going to be talking about today are upper limits. They're not true age estimates. The other assumption, of course, that this candle burning experiment makes is that the rate has been comparable to what it is today. So that's called uniformitarianism, the idea that present rates and conditions are reflective of past rates and conditions. And so if the candle's burning at 1 inch per hour today, we assume it's always been burning at that rate. Doesn't necessarily mean a straight line. Uniformitarianism doesn't necessarily mean linear. It just means whatever it's doing today, that's what it's been doing in the past. So radiometric decay, for example, is exponential. And so the uniformitarian assumption would be it's always been exponential and the constant's been the same. But of course that might not be the case. It could be that there was more oxygen in the room in the past and the candle burned at a faster rate. Maybe it burned at 2 inches per hour when it started and then gradually went down to its current rate. That's certainly possible. And if you didn't compensate for that, your age estimate would be off and it would be inflated by an enormous factor. Now here's the problem. Biblical creationists use different assumptions about rates and initial conditions in their age estimates than secularists use. Okay, my secular colleagues, for example, the University of Colorado, they make different assumptions about the past than I make. And so we end up with different age estimates. It's not that they can't do math or that I can't do math. We can do math just fine. It's just we make different assumptions about the past. And so when we compare, for example, the biblical time scale, what we'd get from a natural reading of Scripture, 6 days and so on, the presuppositions that I would make in my age estimates are very different than what my secular colleagues would make. And by the way, I know that Hugh Ross is not secular. I'm not claiming that. But he would embrace the secular time scale in terms of he would agree with what my colleagues at the University of Colorado would believe in terms of the billions of years. The secular time scale assumes uniformitarianism, the idea that rates and conditions are basically constant. As a biblical creationist, I would not assume that. I assume catastrophism. The idea that rates and conditions might have been very different in the past. And by the way, I'm not arguing that the laws of nature are necessarily different. I'm just saying that rates can change. For example, the worldwide flood would certainly affect the rate at which sediment is deposited. It would affect the rate. Think of the erosion that happened after a global flood. That would certainly be very different than the kind of erosion that takes place today. And so I do not assume uniformitarianism. Secular time scale assumes to some extent naturalism. And again, I'm not saying that Hugh Ross is a naturalist, but that time scale is predicated on the idea that stars and galaxies have formed naturally within the laws of nature. And I don't believe that. I believe that God supernaturally created the universe, that He spoke the stars into existence. He spoke and they stood fast. I believe the Bible clearly teaches that. And so as a result of these different presuppositions, we end up with different age estimates. My secular colleagues end up concluding billions of years of cosmic and geologic evolution. Of course, most of them would include biological evolution as well. But if we take the biblical presuppositions, we end up with creation in 6 days, a few thousand years ago. Now, it will do no good to simply assume uniformitarianism and naturalism, reject the biblical creation and biblical supernaturalism, and then conclude billions of years and say, well, that disproves these things, doesn't it? It does no good to assume this worldview and then argue that proves billions of years and then that disproves this worldview, because in assuming these presuppositions, you've tacitly assumed that this worldview is wrong, which is to say you beg the question. It's a circular argument. And I'm sorry to say that most of the arguments, in fact all the arguments that Hugh Ross used today, assume uniformitarianism and to a certain extent naturalism. So that's to say he's begged the question, because I reject those presuppositions, you see. How can we resolve a debate on worldviews like this? The only rational way to do it is with an internal critique. An internal critique is where you hypothetically assume the starting presuppositions of your opponent and show that they lead to a contradiction. And so I'm not just going to assume my worldview, prove my worldview, and then argue that that disproves the alternative. Rather, I'm going to assume these presuppositions and show that in many cases they lead to a result that is inconsistent with the billions of years. Okay? So I hope you understand that I'm not granting uniformitarianism. I'm intentionally accepting it for the sake of argument to show that it leads to an absurd conclusion. This is a reductio ad absurdum type argument. And there are many lines of evidence that we could use along this way of thinking. The recession of the moon, for example, I brought this up previously with a debate with Hugh Ross. I thought he's had a few years to think about it. He might have an answer to it now. The moon is moving away from the Earth due to tidal forces. And we know that tidal forces go as 1 over r to the 6th power, which means as the moon moves further away, it slows down, which means if you run the movie backwards, it gets faster and faster and faster. And the uniformitarian assumption would be it's always been 1 over r to the 6th, right? And so if you run that movie backwards, you'd find that in 1.4 billion years they collide. And again, that's an upper limit because they can't be closer than 0. Okay, so it's not a problem for a few thousand years where the moon would have just been a few hundred feet closer to the Earth, but it is a problem if you believe the Earth and moon are 4.5 billion years old. Spiral galaxy wrapping. You know, spiral galaxies, they actually wind themselves up with time. The inner portions rotate faster than the outer portions. We can measure that. We can measure the Doppler shifts of those stars. So for example, you have in the Whirlpool galaxy here. That's the linear velocity. When you convert it to angular, the inner portions rotate a lot quicker than the outer portions. And in fact, I've actually been able to simulate this. Let's see if it's going to play. It's not going to play, is it? Oh, well. It wraps itself up ridiculously fast. I'll show you an image of the final result here in just a minute. My secular colleagues say, well, density waves come and form new spiral arms, but they believe the material is very tightly wrapped, in which case the magnetic fields should be very tightly wrapped, because magnetic fields travel with material. They don't travel with density waves. And so we'd expect the magnetic fields would be very tightly wrapped if this galaxy is billions of years old, but in fact, the magnetic fields line right up with the spiral arms, what you'd expect if it's thousands of years old. So basically, if galaxies are 6,000 years old, they ought to look something like that, because they haven't had a lot of time to wrap themselves up. I believe God created them spirals, and they've wrapped just a little bit. This is the result of the simulation. That's for a 1 billion-year-old galaxy. That's what it would look like, based on the measured rates of rotations of the revolutions of the stars. And galaxies are supposed to be 10 billion years old in the secular view. Okay? What do we find? Well, we observe that galaxies look like they're thousands of years old. It's interesting to me because you'll hear people say, well, why does the universe look so old? I'm thinking, what universe are you looking at? Not the real one. The internal heat of the Jovian planets, Jupiter, Saturn, and Neptune, give off more energy than they receive from the sun by a factor of about 2, something like that. And they can't do that forever because they're losing energy, right? They're expending fuel. You can't keep giving away more than you take in unless you're the federal government. But anyway, they can't do that forever. They're going to run out of heat, you see. And so, like take a potato out of the microwave. It's nice and warm. It's radiating that heat to space. Now Jupiter's a bigger potato. It can do that for a lot longer, but it can't do it for billions of years. And that is an issue in the secular view. Magnetic fields actually decay with time. We've actually been able to measure the Earth's magnetic field dropping over, we've been able to measure it for almost 2 centuries. It's an exponential decay from those measurements, and that's what we'd expect on the basis of just basic physics. We'd expect that it would decay exponentially. There is a sinusoidal perturbation on top of that. Now we think during the global flood, the tectonic motions would have affected that magnetic field, disrupted the currents, and you'd cause rapid reversals and things like that. But putting that aside and just assuming uniformitarianism, for the sake of argument, the magnetic field would just have been stronger in the past. It has we can measure the exponential decay. We know it has a half-life of 1,400 years. That means every 1,400 years it drops by a factor of 2. You run it back 6,000 years, it had been 20 times stronger at creation. And that'd be kind of nice because that gives us increased protection from cosmic rays and things of that nature. If you run it back even 50,000 years, the magnetic field would have been 56 billion times stronger than it is today, enough to rip the iron right out of your blood. In fact, if you go back to 60,000 years, the Earth's magnetic field would have been as strong as a neutron star, which is the most powerful magnetic fields we know in the universe. It would rip your atoms apart. So it just can't be that old. Again, assuming uniformitarianism. It can't be that old. My secular colleagues are aware of this. And by the way, it's not just the Earth. The other planets of the solar system, a lot of them have strong magnetic fields. And my secular colleagues said, well, there must be some kind of recharging mechanism, you see. But they have to violate their own uniformitarian assumptions to get that, because the decay appears to be exponential as far as we can tell. And also their recharging mechanism, which they call a magnetic dynamo, predicted that the magnetic fields would be well aligned with the rotation axis of these worlds, and it's not for many of the planets like Uranus and Neptune. It's not even close. In fact, my secular colleagues were expecting that the planet Uranus should have basically no magnetic field at all because it has no internal heat, and you need internal heat to drive that dynamo to recharge the magnetic field, allegedly. On the other hand, my colleague, Dr. Russ Humphreys, he's got a model for how God may have started the magnetic fields. It's really clever, and this is one of the few estimates that is giving us a true age estimate rather than just an upper limit. Based on Humphreys' model, the magnetic field of the planet Uranus should be within that little blue strip that you see there at the top. It should be somewhere between those two values. My secular colleagues believed that the magnetic field should be basically non-existent for the planet Uranus. And when Voyager 2 went past the planet and measured the magnetic field, the measured magnetic field is that. It's consistent with 6,000 years of decay. Isn't that interesting? It's nowhere close to what you'd expect for billions of years. Comets are another example. Comets are balls of ice and dirt, and they orbit the sun on elliptical paths, coming close to the sun and then swinging back out far away. And they lose material when they come close to the sun. And that's what forms a comet's tail. It's material being blasted away. We know the rate at which the material is leaving. We know the size of the comet. You can estimate a typical comet could last no more than about 100,000 years maximum before it totally runs out of material. And yet we still got comets. So if the solar system's billions of years old, why do we still have comets? My secular colleagues said, well, there's an Oort cloud that makes new ones. Basically a comet generator that we can't detect, but it makes new ones every now and then. And they're welcome to speculate on that, but I call that a rescuing device because, you see, I don't think there's any evidence for an Oort cloud. The bottom line is comets are an indication of the youth of the universe, or at least of our solar system, and there's evidence that other solar systems have comets too. So if the solar system is 6,000 years old, that's what we should see. If it's billions of years old, that's what we should see, which is to say we shouldn't see any comets, and in fact we do see comets. Blue stars are another example of the youth of the universe. We find blue stars ubiquitous in spiral galaxies, especially in the spiral arms. And they're beautiful, and they cannot last even tens of millions of years. And my secular colleagues will acknowledge that, because blue stars, even though they have a lot of fuel, they expend it very quickly, kind of like an SUV. They got a big tank, but they don't get very good gas mileage. So they can't last billions of years, and yet we find them everywhere in the universe. Everywhere in the universe. And my secular colleagues won't even argue the age. They know that blue stars can't last long. And so they'll say new ones must be constantly forming. But you know, we've never seen a star form anywhere in the universe, which is interesting. In fact, to get gas to condense and fall into itself and form a star is really problematic. Gas wants to expand. I think you know that. You didn't hold your breath when you came into the room in case all the air should go to that corner. You expected the air to expand and fill the room, and that's what it naturally does. Now, once God makes a star, its own gravity will hold it together. But in space, the force of gravity is tiny compared to the force of gas pressure in a typical situation. So in a 6,000-year-old universe, you'd expect to find lots of varieties of stars. Red stars can last long periods of time. It doesn't mean they're old. It just means they can last that long. Blue stars can't. You'd expect to find both. If the universe were billions of years old, you'd expect only the red ones would be left. Or you'd at least see stars in the process of forming. And what we do see is consistent with thousands of years. Really compelling. Of course, there's a lot of other lines of evidence I could mention that are indicative of youth. And I don't offer these as proof because, as I mentioned earlier, you can't prove scientifically the age of something. I'm just showing you that there's an inconsistency in the secular way of thinking in terms of uniformitarianism and naturalism. In many instances, it leads to results that are inconsistent with its own assumptions. What's the best evidence for creation in 6 days? What's the very best one? You know, it's what God has said in His Word. Exodus 20:11. It's part of the 10 Commandments, written in stone by the finger of God. Verse 8, in 6 days you'll do all your labor, the seventh is the Lord's, and He explains that. And verse 11 is the explanation. Because in 6 days the Lord made the heaven, the earth, the sea, and all that in them is, and rested one day. He did it that way as a pattern for us, using the same word for day, by the way, in the plural form, yamin, which never means a long period of time in historical narrative. So it's very clear that God made in 6 days. It's easy to get intimidated, isn't it? The secular scientists, and there are brilliant scientists out there who say the earth is billions of years old, take my word for it. God says I created in 6 days, take my word for it. Who are you going to trust? That's really the issue, isn't it? That's really the issue. And I'll concede that secularists are almost unified, are virtually unified on billions of years. And so I'm not surprised that Dr. Morris gave the answer he did. Is there any scientist who, apart from Scripture, concludes thousands of years? No. Is there any scientist apart from Scripture that concludes resurrection from the dead? No. And that's something. Well, we have some great resources on this. I'd encourage you to come by and check out our booth. Creation Basics and Beyond is our latest book on the research on these kinds of topics. I've got a book called Old Earth Creationism on Trial. We don't have that here, but you can get it at Amazon. And a lot of the specific facts I mentioned are in my book, Taking Back Astronomy, which I'd encourage you to get and have a look at that. We have a sign-up sheet for our free monthly magazine called Acts and Facts, and I think that would really bless you. Please sign up for that. It's totally free, and we just want to bless you. Check us out on the web as well at icr.org and our special student ministry, youroriginsmatter.com. Thank you very much.